Hello everyone. Let's get started with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. Alright. In the name of the Father, Son, and Holy Spirit. Amen. Sorry about that. Alright, so I hope you guys had a good week. I'm sorry for the 3 videos last week. Hopefully I can get it all in one video this time. Alright, so before we get started, I want to mention something that I noticed you guys were not formatting correctly in your tests. So with complex numbers, we have the real part and the imaginary part, right? So we need to make sure we have them separate because they're 2 separate components of the number. Alright, so if you have a number like this, you need to separate it out like this. Alright, because they're 2 separate parts of the number. So this is not finished. It needs to be separated like this. Alright, let's get started with our lesson for today, which this week we're covering lessons 111 through 115. I had to compress the lessons a little bit since I'm not sure if we missed a week or what happened, but we're going to have a little bit more lessons in the next couple weeks, but we only have 4 weeks left. So if you have extra time at the end of the year, you can spread it out there, but it shouldn't be too bad. Just let me know if it's too much, but we should be getting done pretty quickly. Alright, so let's get started with 3 statements of equality. So this is basically the same thing as having a system of equations with 3 equations. It's just word problems. So for example, we have 26 nickels, dimes, and quarters in all. The value is $2.25. So how many coins of each type are there if there are 10 times as many nickels as quarters? Alright, so we're going to take these 3 statements and we're going to write them as equations. So we can say nickels plus dimes plus quarters equals 26. Alright, when it comes to value, we can put it in terms of pennies, so to speak. So we can have the value of a nickel, value of a dime, value of a quarter, and the total value. So we don't have to deal with decimals. Does that make sense? Alright, and then this last one, we have 10 times as many nickels as quarters. So we'd have 10q equals 10. Alright, so we can use elimination with these 2 and substitution with this one. So we're going to kind of do it all together. Let's put this value for n into both of these equations, so then we'll only have 2 variables. So we get 10q plus d plus q equals 26. And over here, I'm just going to write it all out. Did I forget the q over here? Yeah, I did. Alright, so then we can take these 2 equations, simplify them out, and then subtract. So we get, here we get 11q equals, plus dimes equals 26, and 75q plus 10 dimes equals 225. Alright, so you can subtract that. Hold up, I got lost in my own notes. Okay, so to make these equal, we can multiply this one by 10 and then subtract. So then we get 35q equals 35. Alright, so then we get q equals 1. Alright, then we can put this back into this equation, so then n equals 10. And then use these two values in this equation up here. So then d equals 15. Alright, so that's the 3 statements of equality in lesson 111. So then the next lesson is quadratic inequalities. So we talked about this last week where we got two numbers like this. Alright, so we say they're either both positive or both negative because we have to end up with a positive number. Alright, so we get basically x is less than negative 2 or x is greater than 3. Alright, so what happens if we flip this sign? So then we get x plus 2, x minus 3, less than 0. Alright, so then this has to be negative. So that means they're either one is negative and one is positive, or the other way around. So let's write it out. I'm going to get a smaller pen. Alright, so we get x plus 2 is negative, so it's less than 0, and x minus 3 is positive, or x plus 2 is positive, and x minus 3 is negative. So this becomes a this and this, and a 4 right here. Alright, so then we can simplify this out. So we get x is less than negative 2, x is greater than 3, x is greater than negative 2, and x is less than 3. Alright, so for these, if x is less than negative 2 and greater than 3, there are no numbers that are going to satisfy this. Alright? Over here, if x is greater than negative 2 and less than 3, we end up with a number line like this. Alright? So we end up with this. Alright, this is just a combination of these two equations. Alright, so those are quadratic inequalities. Let's try one more. Alright, so we start with that, we factor it out. Alright, so just like the previous one has to be negative and one has to be positive because it's going to be a negative number. All right, so let's kind of make the same chart as last time. So x minus 2 is greater than 0, and x plus 4 is less than 0, or x minus 2 is less than 0, and x plus 4 is greater than 0. Let's simplify. Alright, so if x is greater than 2 and less than negative 4, there are no numbers that are going to satisfy this one. Alright, if x is less than 2 and greater than negative 4, we're going to end up with a number line like this. Alright, we can write that conjunction as less than 2, greater than negative 4. Alright? Alright, let's go into something a little bit more new called logarithms. Alright, so if we're going to review some rules about exponents to get started. So if we say 10 to the 7 times 10 to the 2, we know that means 10 to the 7 plus 2, or 10 to the 9. Alright? And this can be with any base. Alright, so we also know that 10 to the 7 over 10 to the 2 is the same thing as 10 to the 7 minus 2, or 10 to the 5. Alright, one more rule, 10 to the 7 to the second power is the same thing as 10 to the 7 times 2, which is the same thing as 10 to the 14. Alright, so logarithms work like exponents. Our equation is going to look a little bit like this. We have 10 to the 2 equals 100, right? This is our base. This is the logarithm. Sorry. And this is the anti-logarithm. All right? So this is a simple equation that we already know. Now we're going to see the same values in a slightly different format. Oops, did I write that backwards? There we go. All right, so here we have our base. Here's our anti-logarithm, and here's our logarithm. So the log of 10, 100, 10 times 100 is 2. All right, so the base, this base can be any positive number except, I'm misspelling things all over the place, except 1. Because we know that anything, 1 to the power of anything is always going to be 1. So we can't really use that for logarithms. Alright, so in math, we're going to be looking at things in base 10 and e. Alright, so this is a new number. You've probably seen it on your calculator already. So to get logarithms on your calculator, you're going to enter any number and then press log. Alright, and then that is going to give you the exponent or logarithm. Same concept, different names. Alright, so for example, if we get log of 105, so you enter 105 and then press log, you're going to get a number like this. All right, so the base here is implied. In our calculator, it's set up so that log is automatically base 10. Sometimes it'll give you space to write in a different base, but we're mostly going to be looking at things in base 10 here. So this is the same thing as 10 to the power of this number, so 2, 0, 2, 1, 1, 8, 9, 2, 9, 9, etc., is going to equal 105. All right? Now, E is our new special number, is the natural logarithm. So it's basically the same thing as log of E. Now, we abbreviate this as ln, and it's called the natural logarithm. E is about 2.71828182885, etc. It's a number we're going to use. We're just going to stay with E because this is too long and we'd have to round it and then it wouldn't be exact. So we can look, just like we looked at the log of 105, we can look at the natural log of 105. And so that's going to give us a number like this. So just remember that ln is the natural log, which means the exact same thing as this. All right, we're just talking in base E here. All right, so if we want to use work backwards, just like this original equation, it kind of looks like this one, right? All right, so if we want to work backwards, we can use the inverse logarithm. So we use the exponent to find the anti-logarithm. Here we're using the anti-logarithm to find the exponent. So we'd use inverse log of, for example, .6539 is going to be, hold on, inverse log, we're going to enter the exponent, then inverse log, and that's going to give us the anti-logarithm.